Hello students, this is Mr. Wilsey, and in this video we're going to talk about polynomials. Now, I should have given this paper to you in class, so I want you to get that out, and we're going to be taking notes on it. First of all, we're going to be taking notes on the back side of this. So flip this guy over, and I'm going to give you a list of some examples of polynomials. Now, all of you at the STEM Academy are taking either Latin or etymology, so you should be able to see the pieces of this word. Poly means many. Nomials means I don't know. Pieces, parts, names, I don't know. But many is the key part. Now let me give you many examples of polynomials. 3x plus 1. That's a polynomial. That's also a linear function if it was equal to y, for example. You've seen that before. X squared minus 4. That's a polynomial. G cubed minus 2 times g squared plus g. That's another polynomial. And of course, I don't need to tell you this, but you should be writing down everything that I write down in this video. 7. That's a polynomial. 3 halves times k cubed minus 2/5 k. That's a polynomial. Square root of 3 times j to the 16th power. That's a polynomial. Okay? So here's a whole different variety of polynomials. Now let me show you a few things that are also polynomials, but they look a little scarier. 12 times x squared times y. That's a polynomial. Negative 7 times m cubed times n squared. That's a polynomial. How about these? 9 times x squared times y times z. Polynomial. 3p squared minus 8q cubed plus j to the 4th. Oh my goodness, this is getting crazy. Okay, all of these are polynomials. Now, these polynomials we won't deal with a whole lot in this class. These are the kinds of polynomials that we will deal with in class. These are more simple. There's only one variable, one type of variable in each of these polynomials. Just x in here, just x, just g's. What's the variable here? Well, you could say maybe it's x to the 0 power. X to the 0 is just 1, so it's kind of invisible. It's a ninja. Okay, so these are all examples of polynomials. Now, with examples, let's also think about non-examples of polynomials. What are some things that you might see in this class? I cannot spell today, polynomials. That's why I scratched that out. I couldn't spell polynomial right. What are some examples of things that are not polynomials? Here's one. Square root of x is not a polynomial. It's very simple, much simpler than a lot of this junk, but that is not a polynomial. We will learn later on in this class that if we were to write this with an exponent, this would actually be x to the 1/2 power. That's square root of x. Here's another non-example of a polynomial. X to the -2nd power. Ooh. And we just learned that this can also be written as 1/x squared. Okay, so these are not examples of polynomials. Now, the reason that these are not polynomials is because it's a fractional exponent or a negative exponent. All of the exponents up here are whole numbers, either 0, 1, 2, 3, etc. Now, for this first part of this chapter, we are going to want to do two things with polynomials. Okay? Our goals. We will want to simplify and classify polynomials. Now, when I say simplify, I mean combine like terms. You are already familiar with that phrase, so that should be nothing new to you. We're just going to step it up a notch. And when I say classify, I really mean name. We're going to put a name to all these sorts of polynomials, especially the ones that we're going to look at in class a lot. Now, let me give you an example, first of all, of this first skill of combining like terms, of simplifying polynomials, because it's something that you're already familiar with. So here's one example, and I'm kind of at the bottom of my paper. You might be too. I'm only going to have maybe 3 examples down here. Now, let's say we have a polynomial that looks like this. 2 times k squared minus k plus 3 plus 3k minus 7 plus 5k squared. Let's say that we are asked to simplify that polynomial. That means combine like terms. Now let's try to identify what the like terms are. Now I want you to do this with me, okay? Preferably use a different color pencil if you have colored pencils, or a pen. If you can't do that, that's alright. Just draw shapes. Watch what I mean. I'm going to scan from left to right in here, and I'm going to identify like terms. So for example, I'm scanning, I see 2k squared. Now the k squared is what I'm going to, let's say I'm going to put a box around it, k squared. Now I'm going to continue on to the right, and I'm going to look for other k squareds. Bing, 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 right there, k squared. Okay, I'm done with that. Now, look at the number out front, 2, and then look at the number out front here, 5. In order to combine these two like terms, what I'm going to do is take 2 plus 5, which is 7, and then multiply that by my like term, my like factor, k squared. 7k squared, bada bang, done. Now, I'm going to go through again, and I'm going to look for other like terms. K. Now the k cannot be combined with the k squared, but the k can be combined with other k's. So I'm going to use a different shape, or you could use a different color. I'm going to put a circle around this, and then keep on going, and then a k right here, and then that's it. Now, that's a negative. That means negative 1 is the invisible number multiplying that k. So negative 1 plus 3 is positive 2. So positive 2 times k. Now, as I keep on going, I see a 3 and then a negative 7. Now these, the exponent would be, you could say k to the 0 power, just like this is k to the first power, and this is k to the second power. So they're like terms as well. 3 minus 7, negative 4. Bada bang, done, simplified. Okay? Put a box around that. We worked hard for that. Now let me give you another example. This is going to be a slightly more challenging example. How about this? 4 times m cubed times n minus 7 times m cubed times n plus 8 times m cubed times n. Oh my. What are the like terms in here? Well, in this case, it's that whole piece there. M cubed n. M cubed n, m cubed n, m cubed n. I'm going to put a box around that whole thing. And I'm going to highlight the number out front. The 4, the negative 7, the 8. I can combine these like terms. So what I'm going to do is take 4 minus 7 plus 8, which is 5. And then I'm going to multiply that by the thing I boxed, m cubed n. Okay? That's all there is to it with combining like terms. I want you to do this. I want you to put boxes around the similar pieces, or use different shapes or different colors, whatever. Alright, now flip to the front side of the sheet of paper, and then, as always, put your name up here, in case you lose it. You know who I'm talking about, those of you who keep on losing stuff in my classroom. Okay, let's say we are given a polynomial, like that one right there. So we're going to do an example here, and then you're going to try a similar example here. Now, here is our goal. We want to, first of all, simplify this polynomial, and then all of these steps are going to allow us to classify the polynomial. So we're going to simplify and classify that polynomial. Now, step 1, simplify it. Combine like terms using the same exact skill that we just learned. So I'm going to scan from left to right. I'm going to put a box around similar pieces of each term. So I see an x right here. I'm going to put a box around the x. There's an x there, but it's raised to the third power. Can't box it, but there is an x over here. I'm going to put a box around that guy. Okay? So we have 4 plus 7 is 11 times the x, 11x. Now, are there any other similar pieces? Nope, there's not. So I'm just going to have -1 and plus 5x cubed kind of hanging out. Now, that's step 1. Let's look at step 2. Arrange the terms in order from largest to smallest exponents. So the exponent here is 1. The exponent here is 0. The exponent here is 3. Arrange these terms in order. So the first one would be 5x cubed, largest exponent, then plus 11x, and then minus 1. There we go. The terms are arranged in order from largest to smallest exponents. Now, let's look at step 3. Identify the degree. Now, the degree of a polynomial is the largest exponent that you see. Right here, 3. 3 is the largest exponent. That means the degree of this polynomial is 3. Now, step 4. Name the polynomial by the degree. Okay? Now let me give you some examples over here. So over here, I want you to write next to each of these lines. If the degree is 0, it is constant. We call it a constant polynomial. Let me give you an example. 7. The degree of that polynomial is 0, so we call that a constant. 7 is a constant. It doesn't change because it's not multiplied by a variable. If the degree is 1, it is linear. 3x, what was it? 3x plus 1. The highest exponent is the 1 on the x, so the degree is 1, so we call that linear. You know that, linear. If the degree is 2, like x squared minus 4, if the degree is 2, we call it a quadratic polynomial, x squared minus 4. Now how about this? If the degree is 3, it is cubic, like g cubed minus 2g squared plus g. G cubed minus 2g squared plus g. That's an example of a cubic polynomial. If the degree is 4, we call it a 4th degree polynomial. If the degree is 5, we call it a 5th degree polynomial, and so on, etc. Okay? We just kind of run out of fancy names after we get to 4. Okay? Constant, linear, quadratic, cubic. Now, those of you taking Latin or etymology, look at these 3 words. Linear, quadratic, cubic. Especially the quad and the cube in there. Okay? Think about that. Think about the roots of those words. Alright, now let's go back to our example. The degree is 3, so what kind of polynomial is this? It's cubic. Cubic. Now, we've named this polynomial by its degree. Now we can name the polynomial in a different way as well. we can name the polynomial by the number of terms. Okay? Remember that terms are things that are added together. Now, for example, if there is one term, it is a monomial. So 7 is a monomial because there's only one term. If there are two terms, it is a binomial. So 3x plus, well, how about x squared minus 4? There's only two things that are added or subtracted, so that's a binomial. If there are three terms, like that one, g cubed minus 2g squared plus g, there's three things that are added or subtracted, so that's a trinomial. After that, we just call it like a 4-term polynomial, a 5-term polynomial, and so on. Okay? 4, we kind of run out of steam. Now think, what kind of name are we going to call this polynomial? It's a trinomial. It has 3 terms. Trinomial. Fantastic. Now, step 6, combine the two words to name the polynomial. Okay? First name, last name. Cubic trinomial. Bada bing. So this guy right here is called a cubic trinomial. We have just named this polynomial. Now, what I want you to do now is come back up here to the you try problem. I'm going to get you started. I'm going to help you identify what the like terms are. Okay? So I'm going to scan from left to right. X squared. I'm going to put a box around x squared. I'm going to put a box around the x squared here, and a box around, oh, that's it. That's all the x squareds. Okay? So this means 3 plus 12 is 15. So 15 times x squared. Now I'm going to put a circle around the x's. Circle, circle, circle. Now, you can go on from here. Combine these like terms, and then fill out the rest of this. Fill out the rest of that. And then continue on down until you name the polynomial, first name, last name. Once you get done with that, I have some additional practice for you to do. When I ask you to write in standard form, remember that that just means simplify it and then arrange the terms in order. And then when I ask you to name the polynomial, I'm asking for its first name, last name. Okay? Bada bing, and then bada bing. There you go. Get to it.